Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Electrical Sun and Toroidal Envelopes. Now the sun stops emitting light in all wavelengths detected by the SDO satellite, that is from X-ray to visible light, for periods of up to an hour during the so-called SDO eclipse season, as detailed in article 110 entitled How Do Stars Produce Light? This means that what happens to the sun at this time is not due to an eclipse, but rather due to an encounter between the sun and another celestial body, which results in the sun's ability to emit light disappearing, which in turn suggests that the sun is electrical in nature. Now, we can see what happens here from these two SDO images. We can just see the sun starting to go dark here at the bottom, and then light emitted by the sun becomes less and less, and darkness seems to advance across the surface of the sun. But this is usually explained as an eclipse. But if this was an eclipse, then what we would have here is the Earth covering up the sun, which would be behind it. And if that was the case, then whatever was above this blue line would be visible, and we would most certainly see the corona above the blue line. And we can see there's definitely corona going out to quite some distance from the surface of the sun here, but it's not there. It's definitely not being covered, and it cannot be covered by the Earth, and yet it's not there. And the same thing happens on this side, and this shows that the corona shrinks back as darkness advances across the surface of the sun and cannot be explained by an eclipse. And another thing that shows that the sun is electrical is the fact that comets have developed comas and tails, comet tails, in the solar system. And these can really only be explained as electrical phenomena. And it's not just comets. Asteroids with non-circular orbits also develop a comet tail and a coma when moving through the solar system. And these can be explained as an electrical effect as a result of the sun acting like a capacitor. And the sun then maintains a potential difference between the bottom of the photosphere and the corona, with the bottom of the photosphere maintaining a positive potential respect to the corona. The potential ionizes the material in all of the sun's layers from the photosphere to the corona. The material is thus heated and moves at high velocities in the top layers, which are in the liquid and gaseous phases, namely at the top of the chromosphere and the corona. And the top of the chromosphere would be in the liquid phase, but it's quite viscous, like magma. And then the corona is in the gaseous phase. The movement of the particles becomes turbulent, and thus what we get is the formation of dynamic storm systems. And the very high potential difference also results in extremely energetic lightning-like electric discharges, and these ignite fusion of hydrogen nuclei into helium. So here we see an illustration of what we have in the sun. The core is positive, the photosphere is the solid, but it would be positive on its surface, on its bottom surface, and then we'd have the chromosphere, which is semi-solid at the bottom but more liquid at the top, and then we have the corona, the gaseous phase, and the corona would be negative whilst the interior is positive. Now, the high electric potential difference combined with electrical discharges cause material to be ejected out through the corona and into space beyond the corona. But positive ions experience a greater acceleration as a result of the positive potential of the sun's lower photosphere, because they are repelled by it, whilst electrons are retarded as they are attracted by the positive potential. And this means that the sun's corona will have an excess of electrons, whilst the solar wind will have an excess of positive ions, and the majority of which will be protons. Now, heavier ions will be present as well in the solar wind, and these include magnesium, oxygen, sulfur, nickel, and iron. The solar wind, but many more will be in the solar wind. The solar wind takes these elements all the way to the edge of the solar system, and they accumulate in toroidal or donut-shaped clouds. The lightest elements accumulate in a toroidal-shaped nebula iron cloud, which begins at about the orbit of Jupiter and extends beyond the orbit of Pluto. This cloud contains elements from hydrogen to sulfur, and thus will include carbon, nitrogen, and oxygen. Other toroidal-shaped clouds in disk form at smaller distances from the Sun. The inner such ring will contain the heaviest nuclei, including iron and nickel. And these inner rings are often called zodiacal rings, and we can see a representation of one around the star. The Sun's own zodiacal ring, or inner ring, which contains the heaviest nuclei, is between 900,000 and 1.5 million miles from the Sun's surface. But the Sun also has another 3 stable rings between Mars and Jupiter, and these would contain increasingly lighter nuclei as the distance of the ring from the Sun increases. Now, since rings contain positively charged particles, they form a positive plate of the solar capacitor. So we see the Sun's inner ring here containing the heaviest nuclei, heaviest positive ions. Now, the fact that the lightest elements accumulate in the furthest ring is to be expected, as the least mass particles will be accelerated the most and thus reach the furthest distance in a certain period of time. However, what each ring contain can be worked out from the elements found in the tail of comets as they move through different regions of the solar system on the way to the Sun and then out again and away from the Sun. This is described by James McCann in his book Planet X, Comets and Earth Changes. So if this is the Sun, there would be rings extending outwards towards the furthest reaches of the solar system, and as you can see, the height of these toroidal rings increases with distance from the Sun. Now, the Sun's outer nebular ring would look somewhat like this. So if we were looking at the Sun from outside the solar system, and we were looking at it edge on, this is what we would see. We'd see this cloud. If we are looking at the solar system from above, we would see the Sun and this cloud around it. And the negative capacitor plate is then right outside the surface of the Sun in the corona, whilst the positive plate lies inside the outer nebular ion ring. Now, comets, when they enter the solar system or discharge this capacitor, they quickly gain a charge which is dependent on where they are, and they become negatively charged inside the solar system, and they then start discharging the capacitor. That is, they pull in material in their tails from these clouds of ions, and at the same time a current of electrons moves towards it in the opposite direction. And now the Sun, in addition to fusion reactions which occur as a result of electrical discharges, also has solar flare events. These also occur as a result of electrical discharges which reach a level of intensity beyond the normal and are greater than the continuous electrical discharges occurring in the Sun's atmosphere. These occur when extreme intense weather systems lead to extremely fast spiraling particles associated with extremely intense electric and magnetic fields. When the electric field goes above a critical level, episodic particle creation occurs photons are created, but so are protons and electrons. This is what also happens at an even more energetic level from nuclei of galaxies that are extremely bright. And this is described in Article 126, white holes instead of black holes at the center of galaxies. The light is emitted and the protons are ejected, as are some electrons, but the electrons are decelerated or retarded, as I explained before, as they are attracted to the sun's inner positive potential. So this is an illustration of what happens at a solar flare. We have spiraling charged particles which create a very high electric field. Eventually this electric field reaches an intensity which triggers episodic matter creation. And then what we have is photons. Don't forget, photons, although they are zero mass particles, are still particles. They are created, and then particles with mass, protons and electrons, are created. And if these combine in several arrangements, we may also get other nuclei. And this is the same as what happens in active galactic nuclei as a result, which results in ejection of material, which then condenses into quasars. And this is described by Holton Arp in his book Seeing Red. Now, stars as they age are likely to have a decreased ability to generate the electric potential, which results in the ionization of its surface. This decrease is then likely to decrease the ability to have electrical discharges or lightning, and will thus have result in them having less fusion in their atmospheres. They would not be able to have episodic particle creation, and the cloud of electrons would most likely move closer to the core, and so would the zodiacal disks and the outer nebula ion cloud. The star is thus expected to end up with a toroidal shaped envelope close to its core, which is made up of the heavier elements. These elements were initially in its zodiacal disk. Beyond the inner toroidal envelope is a dispersed cloud of lighter elements up to sulfur, all likely to be found, and this is illustrated in this image. So what we would have is the core. Here it's dark, it's not emitting visible light, and then we have this toroidal shaped envelope formed of heavier elements, and this was what was in the zodiacal disk, but it moved in towards the core. And then we have the other cloud, which has also moved in closer to the core, but it is what it's made up of. It still is the outer nebula ion cloud, but it's moved in much closer to the core of the star now, and this will contain the lightest elements, and that is from hydrogen to sulfur. And this is exactly what we observed in the stellar core, which was observed in 2007, which I now call the 2007 stellar core. And it had an envelope close around the core, which was dark, and there was some light emission from this envelope, so the star was obviously ionizing that material. And there was a cloud of material, you can see something here beyond this surrounding the star, which is represented by this cloud here, the nebula cloud. So as the star ages, the inner toroidal disk comes closer to the core and spreads over its surface, whilst the outer nebula ion cloud also comes closer. And if we take that further, the inner ring should eventually cover the whole core, forming a shell around it, and the outer cloud should form an outer layer around that. In this way, the star would then look like a gas giant planet, i.e. like Jupiter or Neptune, which, this is Neptune. And this is Neptune at the outer edges of the solar system, a gas giant planet. But these objects are not actually planets. they are actually stars, and this should not be surprising because they have electrical discharges in their atmospheres, and which are similar to what is observed in the sun. And in addition, these planets generate much more heat than they could possibly be getting from the sun. They are so far away from the sun. And Jupiter's atmosphere is at a temperature of 1250 Kelvin. And it's impossible that this is due to the radiation that it is getting from the sun. So this shows that these stars have some way of producing heat, and this is most likely fusion, which is ignited by these electrical discharges in the atmosphere. So they seem to retain the ability to fuse elements, but may have lost the ability to produce episodic matter creation events. So in conclusion, the sun is electrical in nature and operates like a capacitor. The sun ejects mainly positive ions as a solar wind and during CME events, which form concentric clouds and disks within the solar capacitor. Comets absorb these materials into their tails, thus indicating where these elements are situated in the solar system. It is also likely that old stars reabsorb the material in these rings and nebula ion clouds as they age and end up looking like gas giant planets. It's thus possible that the sun has captured a number of old stars in the past. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.